Hello and welcome to next lecture. In this lecture we will continue looking at reading data in R. There are other types of formats that you can save data in beyond the tabular format or beyond the CSV file or text file. These are also textual formats, but they are a little bit different from the tabular data that we have talked about before. And the two main functions for writing out data are dumping and dput-ting. And the idea behind these types of format is that they are text formats, but they are not really formatted in the same way as like a table because they contain a little bit more metadata. So data, for example, the type of data in each class or object, for example. If you dump or dput a data frame, it will include in the output that the class of each column of the data frame so that you don't have to specify it when you read it in. And so the advantage of using this type of mechanism to store data or to read data is that you don't have it's still a textual format which can be useful, but it also contains metadata so that you don't have to specify it every single time you read it in, because if the metadata do not get carried with the data set itself, then they can get lost if they get transferred somewhere else. And if you don't remember what the metadata are, for example the classes of the different columns, then you kind of have to reconstruct that from scratch. So that's one advantage of using a function like dump or dput to output data from R. And similarly, the functions for reading data that haven't been outputted from dump or dput are source and dget. So in general, the textual formats are very nice formats for storing data because there's a number of different advantages to them. First of all, they are editable. So if you want to edit, you can edit them. I wouldn't say this is something that I would advise because we want something that's reproducible. But for example, if something gets corrupted, then you can look at the file to see if it's possible to recover it. So textual formats can be a little longer lived. If you are going to be storing data for a long time, sometimes it's useful if it's possible to use a type of textual format so that you can avoid potential problems with corruption. Textual formats can also work better if you are using like a version control program like Subversion or Git, where you are tracking changes between documents, and those types of programs tend to be much more useful with textual data rather than binary data so that you can track changes meaningfully. Textual formats adhere to the general kind of Unix philosophy, which is to store all kinds of data, which generally stores all kinds of data in text. But the one downside of textual formats is that they tend not to be space efficient. So they tend to take up a lot of space, and so it often need to be compressed. So the dput function takes an arbitrary R object and it will take most types of R objects except for some more exotic ones, and it will create some R code that will essentially reconstruct the R object in R. So here's I am creating a small data frame. It's got two columns. The first column is called A, the second column is called B, and then I'm going to dput this data frame, and you will see if you just call dput, it will just output the results to the console. And you can see that what I have done is that it's constructed some R code. For example, it's creating this list that has these two elements in it, and you can see that each element has the data that's in it, and it has the names embedded here. It's got the row names here, and it has the class of the object, which in this case is the data frame. And so all the metadata here like the row names and the names and the class are all included in the output. Now of course you generally don't want to print this to the console. That's not particularly useful. So you probably want to save it to a file. So you can dput the file to a file, and then later on you can read it into R using dget, and when you dget the object you will get this object, and you will see that you have kind of reconstructed the object from before. So the dput function essentially writes R code which can be used to reconstruct an R object. The dump function is a lot like dget. However, the difference is that dget can only be used on a single R object, whereas dump can be used on multiple R objects. And so what you do is what you pass a dump is the character vector which contains the names of the objects. So here I created two objects, one called X, the other called Y, and what I pass the dump are the names of those objects. The names are X and Y, and I give it a file that I want to store the objects in, and then I can remove them if I want to. But to read those objects back into R, I can call the source function on that file, and you will see that the y object and the x object have been reconstructed. So there are a variety of ways that you can interface between R and with the outside world. And generally speaking, there are functions that are used to kind of open up what are called connections to the outside world. Usually you want the most common type of connection, which is to a file. So for example, if you want to read a file, then you can create a file function. You might want to, for example, read a compressed file, or that's a slight variation on that. And most functions will do this in the background without you having to know what's going on. So for example, when you call read.table and you pass it the name of a file, what it does behind the scenes is it opens up a file connection to that file and then reads from that file connection. The connection can be made to other types of objects too. For example, you can open a connection to a web page using the URL function. And so when you open a connection to a web page, you can read data from that web page using the URL connection. And so the idea behind the connection interface is that it kind of abstracts out the mechanism for connecting to different types of objects that are external to R, whether they be files or web pages or whatever. So the file function is the function that opens a connection to a standard uncompressed file. So this can be useful for text files. For reading and other types of text files, gzfile and bzfile are used for opening connections to compressed data files. So gzfile is used for files that are compressed with the gzip algorithm, and the bzfile is for opening connections to files compressed with the bzip2 algorithm. Files that are compressed with the gzip usually have a gz extension, and files compressed with bzip2 usually have a bz2 extension. So the file function here has a few arguments. The description argument is the name of the file, and there's a flag that goes to the open argument, and you have to know what the codes are. But basically R is for reading, W is for writing, A is for appending, and then RB, WB and AB are for reading, writing and appending on binary files respectively. The other options for file are not particularly important at this time. So connections can be very powerful, and they can let you navigate files and other external objects in a more sophisticated way than just like reading the whole thing, for example. And generally you don't have to deal with the connect interface in many cases, but sometimes it's useful. So for example, so here I've got a simple example on opening a file connection to some file called foo.txt. I'm going to open it for reading. I can call read.csv on the connection, and that by default will just read the entire file. Then I can close the connection. So this 3-line process is the same as just calling read.csv on the file. So in this case, there was no need to use the connection to read the file. However, sometimes a connection can be useful if you want to read parts of a file. So for example, here I've got the read lines function, which just reads lines from the text file, and I'm going to open up this words.gz file. So this is a file that has words in it like a dictionary file, and it's compressed using the gzip algorithm. So I'm going to use the gzfile function to open a connection to that, and now I'm going to use this connection and read the first 10 lines. And here the first 10 lines are printed out. As you can see, these are the first top 10 words in the file. And similarly, writelines is a function that can be used to write out lines of text to a file. And what you do is pass writelines the character vector, and each element of the character vector becomes a line in the text file. You can also use readlines to read elements from a web page. So for example, you can use the URL function to create a connection to a website. So this website here is the Johns Hopkins School of Public Health website, and I'm going to open the connection there for reading, and then I'm going to read lines from this connection. And so the lines of text that came from the connection are going to be stored in this character vector X. So when I look at the first couple of lines from X, you can see that it looks like HTML, which is kind of what you would expect. And so the URL function is useful for creating a connection to a kind of non-file object, and then using read.lines is useful to read the text from that connection. So this is another way to read data beyond using functions like read.table or read.csv. So this was all for now on reading data. In the next lecture we will discuss subsetting in R. So see you in the next lecture.